Edge significantly expands the capability of GPRS, enabling richer internet browsing, streaming applications, a greater scope of enterprise applications, and more multimedia applications. With UMTS, users can look forward to video phones, high-fidelity music, rich multimedia applications, and efficient access to their enterprise applications. After completing this section, you will be able to explain the motivation for UMTS, define the advantages of UMTS, explain the path for network evolution from GPRS Edge to UMTS Release 99, define UMTS network components including Node B, RNC, 3GS GSN, etc. Explain the interfaces in UMTS. The Universal Mobile Telecommunication System or UMTS is a third-generation, 3G, mobile communications system that provides a range of broadband services to the world of wireless and mobile communications. The booming mobility market requires new network structure to cope with new user demands. End users are increasingly demanding the consistent user experience with anytime, anywhere access to applications and service environments. 2G networks has limited ability to efficiently provide access to packet data networks like the Internet. Users are looking for access to new applications and services that will require higher speeds, which are currently not supported by GPRS Edge. The UMTS is designed to deliver pictures, graphics, video communications, and other multimedia information, as well as voice and data, to mobile wireless subscribers. The UMTS takes a phased approach toward an all-IP network by extending second-generation, 2G, GSM GPRS networks and using wideband code division multiple access, CDMA, technology. Handover capability between the UMTS and GSM is supported. The GPRS is the convergence point between the 2G technologies and the packet switch domain of the 3G UMTS. UMTS is a step towards an all-IP network. Some key benefits of UMTS are: UMTS network supports higher data speeds as compared to GPRS Edge network. UMTS can support data rates of up to 2 Mbps. UMTS allows simultaneous voice and data capability for users. UMTS supports all advantages of packet data networks such as asymmetric data rates, bandwidth on demand and being always connected. High spectral efficiency. UMTS is based wideband CDMA or WCDMA, which is spectrally more efficient compared to the GSM GPRS. Over-the-edge average performance of 110 to 130 kbps, UMTS provides gain of factor of 2 with average performance of 200 to 300 kbps. As per the 3GPP specifications, following data rates are targets for UMTS: 144 kbps in the satellite and rural outdoor environment, 384 kbps in urban outdoor locations, 2048 kbps in indoor and low mobility outdoor locations. Though the practical throughput may be far lower than these and will depend on multiple factors including what size channels the operator chooses to make available, capabilities of devices, the number of users active in the network and operating radio environment conditions. Edge is an extremely efficient technology for supporting low bandwidth users. WCDMA is extremely efficient for supporting high bandwidth users. for example, 100 kbps and higher. In a UMTS multi-radio network, operators can allocate edge channels to the low-bandwidth users and WCDMA channels to other users, thus optimizing overall network performance and efficiency. Another key characteristic of 3G is the ability for user to use streaming video, web browsing, email and voice call, all at the same time. 3G network handles multiple services simultaneously. To expand the number of applications that can operate effectively, UMTS employs a sophisticated quality of service architecture for data that provides for four fundamental traffic classes, including 1. Conversational. Real-time interactive data with control bandwidth and minimum delays such as voice over IP or video conferencing. 2. Streaming. Continuous data with control bandwidth and some delays such as music or video. 3. Interactive. Back and forth data without bandwidth control and some delay, such as web browsing. 4. Background. Lower priority data that is non-real-time such as batch transfers. This QoS architecture involves negotiation and prioritization of traffic in the radio access network, the core network, and in the interfaces to external networks such as the Internet. Consequently, applications can negotiate quality of service parameters on an end-to-end basis between a mobile terminal and a fixed-end system across the Internet or private intranets. The path of UMTS evolution begins from the GSM voice network. GSM evolved into the GPRS, which shares the access network with GSM, but has a separate packet-based core network. With some coding and modulation enhancements, GPRS becomes Edge, with the 3 times increase in peak data rate capacity. GPRS and Edge network can evolve into UMTS network. The first phase of standardization of UMTS ended around late 1999 to early 2000, and it's generally referred to as Release 99 or R99. It is characterized by change in access technology from TDMA to CDMA. Future releases of UMTS will take a revolutionary step of introducing an all-IP-based network, which uses IP for circuit as well as packet services. Referred to as Release 4 or R4 and Release 5 or R5, these releases pave the way for circuit switching functions such as voice, to be replaced by IP solutions such as SIP, or Session Initiation Protocol. UMTS network architecture, for Release 99, is an easy extension of 2G GSM and 2.5G GPRS networks. UMTS Release 99 incorporates 4 major categories of network elements. 1. GSM Core Network Elements Mobile Services Switching Center or MSC, Visitor Location Register or VLR, Home Location Register or HLR, Authentication Center or OC, and Equipment Identity Register or EIR. 2. GPRS Network Element Serving GPRS Support Node or SGSN and Gateway GPRS Support Node or GGSN. 3. UMTS Terrestrial Radio Access Network or UTRAN Elements. 4. UMTS Specific Network Elements User Equipment or UE. As part of this course we only focuses on the difference between UMTS and GSM GPRS. The Circuit Switched Core Network or CSCN is similar to GSM Core Network with some protocol-level software upgrades. Packet Switched Core Network or PSCN has an evolved 3G, SGSN and GGSN. One of the significant changes in the 3G, SGSN is the addition of a new ATM transport-based interface that is not present in the GPRS, SGSN. The 3G, SGSN also does not perform any radio resource management, logical link establishment or any ciphering functions, which were performed by the GPRS, SGSN. There is no change between UMTS GGSN and the GPRS GGSN. Like GPRS, the HLR is shared between CSCN and PSCN. The HLR maintains a common subscription database for both domains. Another facet of the UMTS is that communication among the SGSN, the GGSN and the UTRAN may go over a private IP network maintained by the operator. A charging gateway function or CGF introduced in GPRS is also present in this network for billing purposes. Both 3G, SGSN and the GGSN have access to the CGF in order to provide billing information. The major difference between GSM GPRS networks and UMTS networks is in the air interface transmission. Time division multiple access, TDMA, and frequency division multiple access, FDMA, are used in GSM GPRS networks. The air interface access method for UMTS networks is wideband code division multiple access, WCDMA. This new air interface access method requires a new radio access network, RAN, called the UMTS Terrestrial RAN, UTRAN. Two new network elements are introduced in the UTRAN. 1. The Radio Network Controller, RNC, that provides functions equivalent to the base station controller, BSC, functions in GSM GPRS networks. 2. Node B, which is equivalent to the base transceiver station, BTS, in GSM GPRS networks. The RNC connects to one or more Node B elements. Similar to the GSM GPRS BSS, the UTRAN Radio Network Subsystem or RNS is capable of both the circuit and packet services. The interface between the UTRAN and the UE is known as the UU interface. The UTRAN reflects one of the fundamental goals of UMTS designers, to provide complete independence between the radio access network and the core networks. This is one of the key reasons why the BSC was changed to RNC, as the radio network functions are handled by the RNC. The UTRAN consists of one or more radio network subsystems or RNS. An RNS consists of one radio network controller or RNC and several Node BS. The radio network controller, RNC, performs functions that are equivalent to the base station controller, BSC, functions in GSM GPRS networks. The RNC provides centralized control of the Node B elements in its covering area. Because the interfaces are ATM-based, the RNC performs switching of ATM cells between the interfaces. RNC talks to core network over the U interface. In GSM GPRS networks, radio resource management is performed in the core network. In UMTS networks, this function is distributed to the RNC, freeing the core network for other functions. A single serving RNC manages serving control functions such as connection to the UE, congestion control, and handover procedures. The RNC also interfaces with other RNCs over the IUR interface to provide mobility for the UE. There is no equivalent of this interface in GSM GPRS networks. Node B is the radio transmission and reception unit for communication between radio cells. Node BS used to be known as Base Transceiver Station, BTS, in second-generation systems. Each Node B unit can provide service for one or more cells. Node B connects to the user equipment, UE, over the UE radio interface using wideband code division multiple access, WCDMA. The IUB interface provides the connection between Node B and the RNC using asynchronous transfer mode, ATM. Node B is the ATM termination point. The main function of Node B is conversion of data on the UE radio interface. This function includes error correction and rate adaptation on the air interface. Node B monitors the quality and strength of the connection and calculates the frame error rate, transmitting this information to the RNC for processing. The interface between UTRAN and core network is called as IU interface. In UMTS, the IU interface to the packet core network is referred to as the UPS interface, and the interface to circuit core network is referred to as the CS interface. These interfaces are used to carry signaling and traffic between the modes. The IU interface defines a suite of protocols for communication between the UTRAN and the core networks. UMTS has prescribed asynchronous transfer mode, ATM, as the mechanism for transporting any communication on the IU interface. The IU interface performs the combined functionality of the GSMA interface and the Edge GPRS-GB interface. The IU interface allows the core networks to request radio resources from the UTRAN. The open nature of the IU interface allows UMTS operators to obtain core networks and UTRAN from different equipment manufacturers. Now that we have seen the architecture for UMTS Release 99, let us put it all together. UTRAN core network consists of a circuit-switched core network and a packet-switched core network. UTRAN provides the radio access connectivity to both the CS and PS core networks. The UTRAN is completely responsible for all the radio-related functions. The CS and PS networks request radio bearers as necessary for the CS and PS services, respectively. The communication protocol within UTRAN and IU interface is ATM. We have seen that the core networks of UMTS is very similar to GSM and GPRS core networks with an addition of WCDMA-based UTRAN. Let's step through the key changes introduced in the UMTS Release 5 or R5. This completes the module. Click Next Topic from Navigation menu.